I have a YouTube channel.
You do?
Yeah, you can subscribe to it.
I want to subscribe.
I don't know what it's called or anything.
Like you have no idea.
Can I have everybody a seat listening? I'm just going to quickly go over this. This is snowball problem number 2, and we're throwing the balls. We're throwing the snowball. It's going to come down, and before we had a person who we were trying to hit who was standing 50 meters from the cliff, but now that person has gotten smart, and they're on a snowmobile, and they're mad, and they're like, right? And we're going to hit them anyway, because we like hitting people with snowballs. And so the question is, how fast do we have to throw it horizontally to hit the person? If you watch number 1, what was the time of the flight? Jack, say that again. 2.02. So our time is 2.02 seconds. Now, how come we can use the same time? Ty.
Just the distance to the ground never changed.
Good. Distance to the ground never changed, and we're throwing it horizontally. So what's our VI vertically? 0. Our initial velocity vertically is 0. It doesn't matter how hard we throw it sideways. Vertically, the velocity is 0. So it's going to take the same amount of time. The question is, how fast horizontally do we have to throw it in order to hit this person? Now, before, we threw it at 25 and we landed right here. If we do that, are we going to hit the person?
No.
No, because they will have driven for 2 seconds, right?
Yeah.
They'll be long gone. Okay, so the next question is, how far does the snowmobile move in 2 seconds?
20 meters. And then added by the.
So we're going to say that this person is driving at a constant velocity, and we're looking for their displacement. So that's velocity times time. Well, why am I not using one of the big 3 and putting acceleration and all that?
Because there is no acceleration.
Good. 0 acceleration. This is moving constant velocity at 10. So we just say 10 times 2 seconds is somewhere around 20 meters. Right? Okay, so how far does our snowball have to go?
70.
We have to throw this 70 meters in 2 seconds, right?
Yeah.
It's 2 seconds because it doesn't matter. It's only gravity that determines the time in the air. Okay, so this is kind of easy mathematically, right? We just say for the snowball, we know that our V equals D over T. I'll leave that marker. And our D is what now? How far does snowball have to go? We need to go around 70 meters in around 2 seconds. So you should have around 35 meters per second. If I aim upward, am I going to hit the guy? No. What if I aim down? No, I'm not going to hit them. Jack.
If we just disregard the 0.02, just round it down.
Ah, okay, Jack, yeah, that's fair. Yeah. 2.02, so it's going to be 34.6. 6 or 7?
6.5.
Confident
6, something like that. A little bit less than 35. Yeah, you're right. If we go 35, we might overshoot them actually. Okay, that's number 2. Number 3 I'll do right now. Standing on the same cliff, 20 meters high. Who wants to throw a snowball? Gordon is going to throw a snowball. Gordon is going to throw, he's not a mean person, Gordon's a very nice guy. He's going to throw the snowball straight up in the air. Okay. Gordon, how fast can you throw?
I don't know,
40 meters per second?
No. Kilometers.
Wow. Impressive.
Kilometers. 20.
Okay. We'll say VI equals 20, and it's straight up. Okay? There's 3 parts to this question. Part A is how long is it in the air? If he goes straight up at 20, it's going to go up and come down and fall down to the ground. Now, I want to explain something here. Everybody stop. Look at me. Danny Watts, you too. Costa, you too. If I drop something, I need something heavier. If I drop this, what's its velocity right now?
0.
0. So isn't the final velocity always 0 if it hits the ground?
Yeah. Well, no.
So in physics, we don't care about what happens after it hits the ground. That's always going to be 0. What we care about is the velocity just before it hits the ground. Okay, so VF is never after it hits the ground. It's always what's happening. Well, why would we care about that rather than after? Yeah.
Calculate the force that it hits with, or
Yeah.
calculate that.
Yeah, if there's like a big asteroid coming to Earth, eventually it's going to be going 0, but do we care about that?
No.
It's like, don't worry. It's VF is going to be 0. It's not going to be a big deal, right? No, it's going to hit really fast and it's going to like implode our planet, right? So we need to know the impact velocity. Okay. Okay, so that's A is the time it takes. And then the B, what I want you to find out is what's the highest point above the cliff? Like how high above the cliff is that snowball going to go? So I'm going to say D max, and this is the vertical. And then let's say, for C,
Well, I hate myself. Like, I guess it's straight up. It's nothing like.
well, we'll give you a little bit of leeway, just a bit. You hold your arm out over the cliff. Throw it. Yeah. It's like a hook shot, you know. Let's say at what 2 times is the snowball 11 meters above the cliff? Now, how do I know there's going to be 2 times? Yes, Brigitte? Well, yeah, probably because it's a quadratic problem. That's mathematically. In the real world, how do I know it's going to go through 11 twice? Danny's going like this. Yeah. Once on the way up, once on the way down. Mathematically, there's going to be a way to give you 2 answers to this. Okay, Chad. Make you think a little bit.
The first one's T, like
Answer. I'll post the answer in the
we're trying
next
to
one.
find the total time, right? For A.
Yeah.